Good evening to all. That is audible.
Yes, sir.
Okay. Okay. Today let us start. Yesterday, due to some that net problem, I was not unable to reach you. Okay. Anyhow, let us start the first model. The first model is on solution of system of linear equations. So in this model, we have to discuss how to solve a system of linear equations using several methods that are given in the syllabus: Gauss-Seidel method, partition method, cross triangulation method, and also it is asked to find the eigenvalues and eigenvectors of a matrix. So this concept you have to discuss in this model. And here, when a system of linear equations given, we have to find a solution. Solution means the values of the unknowns which satisfy all the equations simultaneously. So that values are called solution of the system of linear equations. But when a system of linear equations given, it may possess solution or may not. That can be identified just finding the rank of a matrix. Now first let us see whether the system of given equations possess solution or not. So in order to check that, we have to see what is the rank of a matrix. First, let us see how to find the rank of a given matrix. Now, rank of a matrix. Here, matrix means that is the representation of the coefficient of the unknowns of the system of equations. When you write this coefficient in the form containing rows and columns, that is called matrix of the coefficient. Now, here in a matrix of the coefficient of the that linear equations, each row represent the coefficient of the unknowns of corresponding equation, that means corresponding linear equation. The solution of a system that depends on the number of independent linear equations in the system. So that can be obtained using the rank concept of a matrix. So first let us see what is rank of a matrix. Some matrix may be given. So suppose that it has m rows and n columns. In that m rows and n columns, some rows may be independent, some other may be dependent. Independent means that is not obtained by multiplying any other row by a scalar. Dependent row means that row can be obtained by multiplying any row of the matrix by a scalar or by adding the elements of any two rows of a matrix. If it is obtained by that type of elementary operation, then they are called dependent row. Now, our aim is to find how many independent rows in a matrix. But if a row is dependent in a matrix, suppose that is a square matrix. In a square matrix, some of the rows are dependent means the determinant of that matrix will be always 0. So it is enough to see whether the determinant of that matrix is 0 or not. If it is not equal to 0, then that all the rows will be independent rows. So the rank of a matrix defined as the largest order, or it is the order of the largest square matrix whose determinant is not equal to 0. It is also called non-vanishing minor of the matrix. Non-vanishing minor of the matrix means it is the order of the largest square matrix whose determinant is not equal to 0. So we shall see one simple example. Take a matrix having 2 rows and 2 columns. The first row is 2, 5, second is 3, 8. If you get the determinant of this matrix, you know how to get the determinant. You cross multiply like this, 2 into 8 minus 5 into 3. We get the answer is 1, which is not equal to 0. Since the determinant of this matrix is not equal to 0, this is the largest possible square matrix whose determinant is not equal to 0. Here, because it has 2 rows and 2 columns, it itself is a square matrix. So determinant not equal to 0 means the order of this matrix is here 2. Order means the number of rows or columns of a square matrix. If there are 2 rows are there, so the rank of this matrix is 2 here. Actually, rank represent the number of independent rows. Here the first row is 2, 5. Second row is 3, 8. That means this is also independent row. Suppose that this row is obtained by any multiple of the first row. Suppose that first row is multiplied by 3. 3 into 2 is 6. This 3 into 3 is 5 is 15. If the second row is that one, then the determinant of that matrix will be 0. So our aim is to get the order of the largest square matrix whose determinant is not equal to 0. So the rank actually implies number of independent rows of the matrix. But here, very difficult to work to get the rank of a matrix using this concept. So we see some alternative method how to find the rank of a matrix. So the theory states if there is a dependent row in that matrix, if you apply some elementary operations on that matrix, then the dependent row always vanish. Vanish means that dependent row becomes 0. So to find the rank of a matrix, what to do is just apply some elementary transformations. Then you see how many non-zero rows in the resulting matrix. That always give the rank of a matrix. So to get the rank of a matrix by elementary operations, first let us see what are the elementary transformations or elementary operations on a matrix. So for that, you take any matrix having some m rows and n columns. One elementary operation is that is just interchange of any two rows. In a matrix, just interchange any two rows, or it may be any two columns also, but not a row and column. Then it gives the rank of transpose of a matrix. Either interchange any two rows or any two columns. So this type of operation, it is called one elementary operation. Usually this type of operation is denoted by the symbol. We just write r suffix I interchanged with r suffix j. That means ith and jth rows are interchanged. So this is one operation. Another operation is that you multiply any row of a matrix or any column of a matrix by a scalar. That means by a non-zero real number. It is another operation. It is also called elementary operation. So this operation is usually denoted by the symbol. Suppose that we are multiplying ith row of a matrix by a scalar k. Then we denote this one by this symbol ri, put an arrow mark only. That means r suffix I, that is replaced by, so arrow mark shows it is replaced by k times ri. Suppose that third row, you multiply 3 into that row, means multiply every element of the third row by 3. Then that operation is written as R3 is replaced by 3 times R3, like that, if you're multiplying the third row. So this is another operation. One more operation is that is, you can add the elements of, that means corresponding elements of any two rows, or one row may be multiplied by a scalar, another row multiplied by another scalar, then add the corresponding elements. That type of operation is that is called the third elementary operation. So in a matrix, operation means there are three type of operations. One is interchange of any two rows, another is multiplying any row by a scalar, third one is addition of the elements or addition of the elements of any row to the corresponding elements of any other row, which is multiplied by a scalar. So these three operations are called elementary transformations or elementary operations on a matrix. But if you apply this type of operations, then if a matrix given, if some of them that means sum of rows are dependent, then whenever you apply this type of operations, the dependent row always becomes 0. So this concept you can use to find the rank of a matrix. Actually, finding the rank of a matrix that indicates to identify the number of independent rows of the matrix. So whenever you are asked to find the rank of a matrix, what you have to do is just apply these three operations on the given matrix so that the resulting matrix, that means the given matrix, reduces to upper triangular form. What do you mean by upper triangular matrix? Upper triangular matrix means if all the elements below the diagonal of a matrix are 0, above the diagonals are non-zero, then it is called upper triangular matrix. So applying this type of operations, only these three operations you have to apply, you reduce the given matrix to upper triangular form. Then that form is also called echelon form. So this echelon form is nothing but when you reduce the given matrix to upper triangular form, that matrix obtained is called echelon form. Once you reduce the given matrix to echelon form, in that echelon form matrix, count how many non-zero rows are there. What in by non-zero row? If at least one element is not zero in that row, then it is called non-zero. If all the elements are zero, that is called zero row. So you just count how many non-zero rows exist in the echelon form. Echelon form means should know just reducing the given matrix to upper triangular form. All the elements below the diagonal must be zero. Then that is called upper triangle form. That is called echelon form. That the number of non-zero rows that gives the rank of a matrix. And when you apply any elementary operation to the given matrix, that matrix obtained from the given matrix, it is called equivalent matrix. So equivalent matrix means matrix obtained from the given matrix using any one of the three operations. So how to get the rank of a matrix? To get the rank of a matrix, what you have to do is just reduce that given matrix to upper triangular form, which is known as echelon form. Once you reduce to that, then the number of non-zero rows in the upper triangular matrix, that is gives the rank of the matrix. Actually, rank means it represents number of independent rows. Actually, that is independent that linear equations in the system. When a system of equations given, how many independent equations are there, how many dependent equations are there, that counts whether the system has solution or not. So using this concept, we can find the rank of a matrix. Let us say one illustrative example. Suppose that is asked to find the rank of the matrix. Sometimes the exam they may ask for 7 or 8 marks, or sometimes they ask 10 marks also. Find the rank of the matrix. One matrix is given, that is the first row is here 0, 1, minus 3, minus 1. Second row is 1, 0, 1, 1. Third row is 3, 1, 0, 2. And last row 1, 1, minus 2, 0. Actually, we have to find rank of the matrix, that is actually equal to number of independent rows. How to get this? That I told the method, just to reduce to upper triangle form. So before that, let us check the rank by this concept. How many independent rows? If you do like that, that will be objective question. So you directly can write the answer. So for example, you see here first row is 0, 1, minus 3, minus 1. Second row is 1, 0, 1, 1. There is no particular relation between these two rows. So we shall consider these two as independent rows. Now, what about the next one? Whether it's independent or not? We shall let us see any relation between this row and any other row of this matrix. For example, third row is here 3, 1, 0, 2, 1. And what about this second and first row? You see, if you multiply the second row by 3, and if you add to the first row, see what happens to this. Here, second row is 1, 0, 1, 1. When you multiply this one by 3, we get this 3. It is 0, it is 3, it is 3. Then you multiply the corresponding elements of the second row and first row after multiplying second row by 3. So what happens? This 3 plus 0, 3. So that is there. Here it is 0. It is multiplied by 3 means 0 only. Plus this 1. What is that? 1. And here, when you multiply this 3, 3 plus this 1 minus 3 means 0. Here 3, 0 is there. Here it is multiplied by 3 means 3 plus minus 1, it is 2. So this third row, how you obtain? By multiplying the second row by 3 and adding to the first row, you obtain this. So this is treated as dependent row. This row depends on this type of elementary operations on second and first. Similarly, how you got the last row, you see? Here the elements are, you just obtain by adding the second and first row, because second row is this one, is the first row. If I add these two rows, what happens? 1 plus 0 here, that is 1, it is there. And here 0 plus 1, that is 1, that is here. This is 0, sorry, this one 1 plus this minus 3. 1 plus minus 3 means minus 2. So minus 2 is there. Here 2 plus, sorry, this one 1 plus minus 1, it is 0. So this last row you obtain by adding first and second row. So third row is dependent row, last row also dependent row. So how many independent rows? Only first and second. So here this matrix has only 2 independent rows. The next 2 rows are dependent. Rank of a matrix is treated as the number of independent rows. Here it has 2 independent rows. So rank of the matrix is 2 here. That just you can get by just analyzing this problem. But the question is asking the exam, find the rank of matrix. You just write 2, they won't give 10 marks. They are out to show the steps. For that, let us see what is another method of finding the rank, just using elementary transformation technique. Or in the exam they mention determine the rank of the matrix by applying elementary transformations or by reducing to echelon form. So what you mean by echelon form is just you have to reduce this matrix to upper triangular form. But we have to apply only that 3 operations. Using that 3 operations only, we have to reduce this one to upper triangular form. So let us see how to do this. So first, to get the rank of this matrix, what you can do is to take this matrix is equal to A. Let A is equal to the given matrix. The first row is the same one here written is the given matrix. Our purpose is to reduce to upper triangle form. So upper triangular form is here the diagonal elements are 0. First, you have to make the first element in the first row non-zero. How to make the first element in the first non-zero? Any operation you can't do, only that 3 operations you have to perform. So there the first operation mentioned, what is that? Interchange of any 2 rows, that is permitted. So here, to make the first element of the first row non-zero, we can interchange with any rows of this matrix other than first. But if this first element is 1, that helps us for the next type of operation. So since this should be 1, I can interchange this first and second row or first and last row. In both cases, it is possible. But for convenience, I'll take the second and first. I shall interchange these 2 rows. So first operation we have to do is make this first element first row non-zero. For that, interchange these 2 rows or first and last. So here I have done this operation. We just interchange the first and second row. It's shown by this symbol R1 interchange with the R2. When you interchange, what happens? The second row goes to the first one. Just take the first place. Who is in the top, that comes to the next. So here you get the matrix by just interchanging first and second row. So first row is here 1 0 1 1, which was the second row of the given matrix, and where the second row in the given matrix that took the first place here. So 1 0 1 1 0. That only the operation done. But to get the rank of a matrix, as you like, you don't apply the operation. In this order, you have to perform. First step is making the first element, first row, non-zero. After that, make all the elements below that element zeros. So this is already zero. You have to make this element also zero, this also zero. So in this order, you have to perform. Otherwise, we get some confusing answer. To avoid that, in this order, you have to proceed to get the rank. First step is see whether the first element in the first row non-zero. If so, make all the element below that element zero. For that, here in the second row, first element is already zero. The third row, first element must be zero. To make it zero, you have to perform any one of the operation you have mentioned earlier. There are three operations mentioned. One is interchange of unit row, another is multiplication row by a scalar, then just addition. So in this case, to make this element zero, what operation you can perform? But this operation must be with respect to the first row. That means you have to keep in mind that all the elements in the first column are made zero with respect to the first row, and all the elements in the second row or second column are made zero with respect to the second row. In that order, you have to proceed. So to make the elements under first column zero, you have to consider the first row for the operation. So with respect to first row, you have to make this element zero. In the third row, first element must be zero. For that, here 3 is there. When you multiply the first row by 3, what happens? This becomes 3. So 3 minus 3 is 0. So to make this element 0, that means the third row, I perform this operation. That is, third row, that is R3, is replaced by R3 minus 3 times R1. Similarly, to make this element 0, that is in the fourth row, first element, to make this element 0 with respect to first row, what operation can perform? This is 1, this also 1, means R4 minus R1. R4 minus R1 means this element becomes 0. That operation, let us write here. For R3, the operation is R3 minus 3 times R1. And for R4, the operation is R4 minus R1. When you apply these two operations, what happens to this matrix that's shown here? That becomes, there is no operation for the first two rows as itself. First row is 1, 0, 1, 1, here written. Second row also 0, 1, minus 3, minus 1, that is written. The next row is third row minus 3 times the first row, means 3 minus 3, it is 0 here written. Next, this is 1 minus, it is multiplied by 3, that means 1 minus 0, this is 1. And for the next element here, it is 0 minus, it is multiplied by 3. 0 minus 1 into 3, it's minus 3, it is written. Next, for this, it is 2 minus, it is multiplied by 3. 2 minus 1 into 3, that is minus 1, that also written. And for the last row, the operation is, that is R4 minus R1. That means here it is 1 minus 1, it is 0 written. This is 1 minus this 0, it is 1. This is minus 2, here it is 1, minus 2 minus 1, it is minus 3, it is written here. It is 0 minus 1, it is minus 1. So you got this matrix. Now the next step is, you have to make the first step, all the elements in the first column 0 except the first element. Next, in the next step, what to do is, you have to make all the element below the second element of the second column must be 0. First select the second column, there, this is the second element, all the element below this must be 0. Next, for the third column, see the third element, all the element below that must be 0. In this process, in this order you have to go. So in the second stage, you have to make the elements in the second column 0 under the second element of that column. So this is the second element of the second column. These two elements must be 0. But these two elements are made 0 with respect to the second row only, because all the elements are made 0 in the second column with respect to the operation on second row. So to make this element 0, what to do? That is in the R3, third row, separate with the R2. R3 minus R2 is 0. And for this one, R3 minus R2 only have to do, but don't write R3 minus R2. Then this will be 0. But what you made 0, that will become non-zero in that case in some other operations. So here the operation for third row and fourth row. So what's that operation? For third row minus second row, so that this element becomes 0. To make this element 0, that fourth row minus the second row, that is written here. R4 is replaced by this much. So when you apply this operation, what happens? The first row as itself, no change. The second row also as itself, no change. What about the next one? 0 minus 0, 0, 1 minus 1, 0, minus 3 minus 3, 0, minus 1, 0. Similarly, the last row all become 0. Now it is reduced to echelon form because all the elements below the diagonal are 0 I got, all are 0 below this. So this form of a matrix is called echelon form. So no need of mentioning which this one. What is done here, that is echelon form. Here, number of independent row of the matrix we need, that is equivalent to number of non-zero rows of the matrix. If a row is dependent, if you apply that operation, all becomes 0. This is dependent row, this is also dependent, all made 0. So here, how many non-zero rows? This is non-zero row because some non-zero elements are there. This also non-zero row. This is 0 row, this is 0. So only 2 non-zero rows are there. So rank of this matrix is nothing but number of non-zero rows, that is equal to 2. Like they can find the rank of a matrix. Very simple concept you studied earlier in your UG classes. Once again you are repeating this, right? So that is how to get the rank of a matrix. Now here the elements are of this type, easily can do. Sometimes the elements of matrix may be 2 digits number. So suppose that it is like this. The question is asked, determine the rank of a matrix. The first row is here 5, 6, 7, 8. Second row is 6, 7, 8, 9. Third row is 11, 12, 13, 14, 16, 17, 18, 19. And here it is to check, as I told in the previous example, whether it is dependent, independent. It is a tedious work. Instead of checking that, if you apply row operations, if it is dependent, then it will automatically become 0. So no need taking risk for that by checking whether it's multiple of any other row or etc. What you can do is just reduce to upper triangular form. But here, to minimize the work, when 2 digit number, 3 digit numbers are given, so instead of 5, it may be 500, this may be 561, like that. That complete numbers may be given. In that case, to get the rank, it is very difficult also how to make it 0. So what you can do is this. For that, I'll show this one in this example. First step, what to do is take the given matrix as A. So this is the given matrix. Here, next, you just have to see how to make the upper triangle form. If you do actual operation, it is time consuming. What you can do is, you can larger number can be changed to smaller number, just taking any one row as a reference. You separate all other rows, elements from that reference row. So in this case, first operation randomly I'll do without keeping any goal in the process. For the second row, I replace second row minus first row. For third row minus first row. For fourth row minus first row. My aim is to minimize this numbers, what is presented here. So if you apply this, what happens you see? Applying R2 minus R1, R3 minus R1, for R4 minus R1. If you do like that, see what happens. The next step you get like this. The first row, no operations performed. So as it's a 5, 6, 7, 8. The second one, for the second row, what is the operation here written? R2 minus R1. If you do like that, 6 minus 5, 1, 7 minus 6, 1, 8 minus 7, 1, 9 minus 8, 1. Here 1, 1, 1 you got. Next, for the next one, that R3 minus R1 means you got like this. 11 minus 5 is 6, 12 minus 6, 6, 6, 6, like that you got. Now it is easy to search how many independent rows are there. Or we can reduce to upper triangular form, right? So as I told in the previous step, if you make the first element first row 1, using that operation, that minimizes the next process. So to make the first element 1 here, you can interchange the first row with the second row. If interchange, what happens? That same matrix you get, same matrix what is written in the previous slide, only changes first and second rows are interchanged. Then it takes this shape. Now, To reduce this one to upper triangle form, all the elements below the diagonal must be 0. Now first to go for the first column. The first column except this one, these three numbers must be 0. How to make this element 0? To make this element 0, this is in the second row. Second row minus 5 times first row means what you get? 5 minus 5 is 0. For the third row, the 6 minus 6 into R1. So that 6 minus 6 becomes 0. For this one, 11 minus 11 into R1. So that this becomes 0. So my aim is to make all these three elements 0. So I perform this operation. For the second row, R2 minus 5 times R1 to make this element 0. Therefore, second row. For third row, this must be 0. For that purpose, this row minus 6 times R1. So that is written R3 minus 6 times R1. So element 0. That fourth row minus 11 times R1. If you apply this operation, what you get in the one step itself, we got this is 1 1 1, this 5 minus 5 0, 6 minus 5 1, 7 minus 5 2, 8 minus 5 3. But the next, this is 6 minus 6 0, 6 minus 6 0, all this becomes 0. Now it's automatically reduced to upper triangle form. So how many independent rows? That means how many non-zero rows in this matrix? This is non-zero row, this is non-zero row, this is 0 row, this is 0 row. So 2 rows are there. So rank of this matrix also 2. So like that, we can get the rank of a matrix just by applying elementary transformations. So I'll go for one more example. See, this is a third problem. It is asked to get the determinant of this matrix. So first step is take the given matrix is equal to A. Then operation is you have to make all the elements below the first element of that first column must be zeros. But in the previous two problems, I made the first element 1, then I made all the remaining elements 0. But it is not necessary, right? For example, in this case, in this example, I will show this one in another form also. Whatever you do, final answer will be same. Here, to make this element 0, you can multiply this row by 2, then add to the first row. So 2 plus minus 2 is 0. Again for this 2 plus minus 2 is 0 means multiplication by 2 and add it. These operations are possible, not necessary to interchange this. If it is also no problem. So without interchange, I will do first here like this. For the second row, 2 times R1, R2 plus R1. For third row, 3 times R1 plus 2 times R3 plus R1. If you apply this operation, what you got? The first row is as usual. Here, as usual, you just see this calculation. This is 0. Everything will get it. 0, 0, 0 you got. This is the row because this 2 plus 2 into 2 is 4. Plus minus 1 is 3. 2, this one is multiplied by 3 into 6. And add to this, we get this element, right? Next, to make the further element 0, this element must be 0, multiply by 3 and add it. For this one, multiply 3 and subtract. If you apply this operation, we get this matrix. Again, it's not completed. All the elements below diagonal must be 0. This element 0. This must be 0 now. To make 0, you add these two elements. So that means operation for fourth row plus third row. If you do like this, you got it. Here, all the elements below diagonal made 0, but there is no 0 row in this matrix. All are non-zero rows. So what is the rank of this matrix? Rank of the matrix is equal to number of non-zero rows. Here that is equal to 4. So like that, you can find the rank of a matrix using this type of elementary operations, right? So like that, another example is given. You can try for this one also. Only 3 minutes, 4 minutes remaining. So just I'll show how it is done. Take all these examples and try yourself. Just I've shown the method only because you have to practice this one. Usually sometimes more than this, maybe 5 by 5 matrix may be given. You have to get the rank. The concept you should know. For 10 marks means any type of matrix will be given. You have to get the rank. So how it is done? Just take this given matrix. Again, apply the operation like this to make this element 0, multiply it by 2 and subtract with the first row. This is the operation written. R2 is 2R2 minus R1. For R3 also R3 minus 2R1. We perform like this. We get this matrix. Again, I have to make this element 0. One method is we are making this in one. It's not necessary. You this row minus 3 times the second row, so that 3 into 6 we get. We can make this element 0. The same operation apply for the fourth row also. So what is the operation to be performed here? That is applying this operation for R3 minus 3 times R2. For R4 also, that R4 is replaced by R4 minus 3 times R2. If you do this operation, simply we get this matrix, right? See the elements and perform the operation yourself and return all the values here, right? So next, one more operation required. All the elements below the diagonal must be 0 to convert to echelon form. To make it 0, what you can do? Multiply the third row by 2, then subtract third row from the fourth row. So operation for the fourth row is R4 is replaced by R4 minus 2 times R2, R3. Finally, we get this matrix. Here also, no 0 row is there, but reduced to upper triangle form. It's called echelon form. Hence, rank of the matrix is equal to here number of non-zero rows, that is equal to 4. So like that, we can find the rank of a matrix. Now, why we need this rank? Actually, it is to test the consistency of a system of equations. When a system of equations given, usually a system of equation given like this, say one equation, let it be a11 into x1 plus a12 into x2 plus etc. a1n into xn is equal to b1. This is the first equation. Second equation may be given like this, a21 into x1 plus a22 into x2 plus etc. a2n is equal into xn is equal to b2. Like that, a system of equation may be given like this. To see whether the system has a solution or not, we can find the rank of this matrix, of the coefficient matrix, and you can check. But how we can do this one, I'll continue in the next class because time is over. Now only 1 minute is remaining. So we shall continue tomorrow and see how to test whether the system has a rank or not. Okay, thank you all.
Thank you, sir.
Okay.